First, in this paper, you have to study all the spectroscopies: IR spectroscopy, NMR, mass spectroscopy, and fluorescence spectroscopy. Okay. So the first lecture we are starting the IR spectroscopy, infrared spectroscopy. It is called infrared spectroscopy. So in last year we have studied UV visible, atomic absorption, flame emission, etc. So what are the basis spectroscopy? What is the spectroscopy? Firstly, we must know what is spectroscopy. Hello, पावडे आवाज येतोय का माझा?
आता येतोय सर.
येतोय ना? Okay. So we are starting the IR spectroscopy. In the last year we have studied what is spectroscopy. It is the interaction of electromagnetic radiations with matter. That is called the spectroscopy. Now when we use IR region, तुमच्याकडून कनेक्शन जातंय का बार बार? हॅलो,
आमचं नाही जात सर, तुमचं डिस्कनेक्ट होतं.
हा, माझ्याकडे नेहमी मीटिंग मधून बाहेर येऊन पुन्हा लॉग इन व्हावं लागते. ओके. So when we use infrared radiations for the study of interaction of this spectroscopy, that is called infrared spectroscopy. Now in infrared region, the vibrational excitations are taking place in that molecule. That molecule undergoes vibrational excitation. There is changes in vibrational energy level of molecule. So this spectroscopy is also called as vibrational spectroscopy. Vibrational spectroscopy or infrared spectroscopy. Okay. Now we have studied electromagnetic spectrum. This is the electromagnetic spectrum. This is electromagnetic spectrum. Okay, showing various regions of this spectrum. So these are the gamma rays. This up to this wavelength 10 raised to power 19 frequency 10 raised to power 19 hertz, or the wavelength equal to 10 raised to power minus 11 meters. That is gamma rays. These are the X-rays. This is ultraviolet, visible. After visible, then comes infrared region. Means the infrared radiations has lower energy than the visible radiations. Up to this, we have studied last year UV and visible. Okay, UV and visible radiations we have studied last year, UV visible spectroscopy. Now in this unit, we have to study the infrared spectroscopy. This is the part of electromagnetic radiations from 1 microns to 100 microns wavelength. We may say this is infrared region. This infrared region is from zero point 0.4 to 1000. 0.4 to 1000 micron comprises of infrared region. Okay, this is the infrared region, range of infrared radiations. What is the wavelength range of infrared radiations? It is from zero point 0.8 micrometer to 25 micrometer, sorry, 1000 micrometer. Zero point 0.8 micrometer to 1000 micrometer wavelength range is called as infrared radiations. Okay. Again, this much range is divided into three parts. The infrared radiations were divided into three parts, just like ultraviolet. That is the near ultraviolet and far ultraviolet were divided into two parts. But these IR radiations were divided into three parts. Near IR, near IR radiations, it is called overtone region. What are overtone? We are see later on. So the near IR region consists of zero point 0.8 micrometer to 2.5 micrometers. In infrared spectroscopy, we use a per centimeter wave number to describe the absorption of the radiations. So the near infrared radiation has 12,500 to 4,000 wave number per centimeter wave numbers. After that, near infrared, near means it is near to visible radiation. That is near infrared. Just after visible radiation, just after visible radiations, that much part from 8 micrometer means at 800 nanometer, 800 nanometer to 250 nanometer, sorry, 25,000 nanometer. It is called as near infrared region. In this region, or it is called as overtone region also. Then the middle infrared region. Second is the middle infrared region. This region falls from 2.5 micrometer to 50 micrometer. This is vibration rotation region. In this region, vibrational and rotational excitations are taking place in middle infrared region, 0.25 micrometer to 50 micrometer. Its wave number range is 4000 to 200. Mostly this region is used for the study of infrared spectroscopy. आपण infrared spectroscopy study करण्यासाठी this region हे 2.5 मायक्रॉन to 50 मायक्रॉन एवढंच वापरतात. Then comes far IR region. In far IR region, rotation, it is rotation region. Only rotational excitations are taking place. Last year we have studied what are vibrational excitation, what are rotational excitation. The change of molecule from one vibrational energy level to higher vibrational energy level is called as vibrational excitation. Okay. So the far IR 50 micrometer to 1000 micrometer, it is the far infrared region. So for organic chemist or in a chemist, mostly for study of infrared spectroscopy, we use this middle infrared region, 2.5 micron to 50 micron wavelength region. Okay. Now, what is the principle of IR spectroscopy? Just like other spectroscopies, when we pass infrared radiation through the sample of organic compound or inorganic compounds, then the some part of that radiations what absorbed, some part of that radiations was absorbed and remaining other part is transmitted as it is. Now, what happens when the radiations were absorbed? What with that absorbed radiations? That radiations, absorbed radiations, has same energy just as the energy gap between two vibrational energy levels. दोन व्हायब्रेशनल एनर्जी लेवल्स मध्ये जेवढा एनर्जी गॅप असतो तेवढ्या एनर्जीचे इन्फ्रारेड रेडिएशन्स ऍब्सॉर्ब होतील. When these infrared radiations were passed through the sample and remaining radiations were transmitted as it is. Now when we analyze the transmitted radiations, then we found that some part is missing, some part of that incident radiations is missing, that we call it as such, that missing radiations were absorbed by the sample and remaining radiations were transmitted. Okay. Now we have to find out what percent of radiations were absorbed and what percent of radiations were transmitted. what percent of radiations were absorbed and what percent of radiations were transmitted. Suppose we have irradiated 100 waves, 100 radiations through that sample, and 10 radiations were absorbed, 90 radiations were transmitted. Then its transmittance is 90%, as 90 radiations were transmitted. Transmittance is 90%, absorbance is 10%. Absorbance is 10%, transmittance is 90%. So in infrared radiations, in infrared spectroscopy, we plot a graph as transmittance versus wave number. Transmittance versus wave number. Just like in UV visible spectroscopy, we are plotting absorbance versus wavelength. On x-axis, we take wavelength. On y-axis, we take absorbance, and we get dome-shaped graph. At maximum absorbance, the graph has maximum steep point, upper direction. Okay, but here we have to plot percentage transmittance on y-axis, and the wave number, instead of wavelength, we take wave number on x-axis, and we get graph. The peaks bands were on downward direction like this. Just we have seen on first slide. That is the infrared spectra. That is the infrared spectra. Okay. So the in principle, this is the infrared spectrum of aniline. Okay. This peak represents, now it is the percentage transmittance. It is 0.2%, 4%, 6%, 8%. Now if percentage transmittance is higher, then the absorbance is less. If transmittance is more, then the absorbance is less one. Okay. So these less transmittance, these peaks represent the absorbance is higher one and the transmittance is lower one. Absorbance is higher here, transmittance is lower. So and the y-x-axis we take wave numbers. These are the, this is the wave number scale, 3000, 2000, 1000. And one more peculiarity is there, one more typical character of this infrared spectrum. On x-axis, we are not taking linear scale. We are not taking linear scale for wave numbers. Okay. So this is the infrared spectra, and these bands represent that at this wave number, say it is 30,050 per centimeter. At this 30,050 per centimeter, some part is absorbed, absorbance is more, and transmittance is less. Suppose this is at say 32,000, 3200 per centimeter. At this absorbance is more and transmittance is less. Instead of showing absorbance, we show transmittance on y-axis. So these are the bands. This is called sharp and then more absorbance, whereas less 0% transmittance. So this is the principle infrared. Now we will see what are the requirements to absorb infrared radiations. What are the requirements to absorb infrared radiations? Now correct wavelength of radiation. The molecule is vibrating. In infrared spectroscopy, there is change in vibrational energy levels. In infrared spectroscopy, there is change in vibrational energy levels of a molecule. That means there are vibrational excitations. So that molecule has some original vibrational frequency. That molecule vibrates with some original frequency. Okay. Now the radiations which has same frequency as the molecule is vibrating, then such radiations were gets absorbed and other radiations were transmitted as it is. So first necessary condition is that the molecule, the radiations has equal natural frequency of vibration of some part of molecule. Some part of molecule is vibrating. Suppose the uh, there is a hydrocarbon. CC bond is vibrating at somewhat frequency, whereas CH bond is vibrating with some other frequency. CH bond is vibrating with some other frequency, whereas CC carbon carbon bond is vibrating with some other frequency. Okay, so if the radiations have same frequency as CH is vibrating, then such radiations will get absorbed. Also, the radiations having frequency C bond vibration, then those radiations will get absorbed, and remaining vibrations, remaining radiations, which are not equal to such vibrations, vibrational frequencies, they were transmitted as it is. So, if that radiation we have given to that molecule does not have frequencies equal to any part of that molecule, then such radiations were not absorbed. All radiations were transmitted. So, the necessary condition is that the radiation should have correct wavelength or correct frequency. At least some part of that molecule vibrate with that frequency. This is the one requirement. Another one is electric dipole. Another one is electric dipole. That molecule must be polar. Polar means what? Like this HCl. In HCl, this bond is not 100% covalent or 100% ionic. This bond is called as polar bond. This bond is called as polar bond. It has electric dipole, two opposite charges on the two molecules. So it is called electric dipole. So that molecule must contain electric dipole, because we have seen what are electromagnetic radiations. This electromagnetic radiations has two components, electric component and magnetic component. So we may say that the electric electromagnetic waves has fluctuating electric currents. It has fluctuating electric current. The same way, if this molecule is vibrating, here also fluctuating electric field. Due to vibration of this molecule, the electric field is fluctuating in this molecule also, and the electromagnetic radiations is also having fluctuating electric field, and those two electric fields interact with each other. Okay. Now the molecules having homoatoms, say nitrogen, chlorine molecule, ClCl, these molecules are non-polar. These molecules are non-polar molecules. They don't have electric dipoles. If you take chlorine molecules, both chlorine has same electronegativity. So that the shared pair of electron resides exactly at the center of two atoms. Exactly at the center of two atoms, and both the chlorines are neutral. They don't have any charges. So there is no electric dipole. So such atoms do not absorb infrared radiations. Why? Because due to vibration of such atoms, the fluctuating electric field is not produced. असे atoms जर व्हायब्रेट झाला, असा मॉलिक्यूल जर व्हायब्रेट झाला ज्याच्यावरती चार्जेस नाही आहेत, then the electric field is not produced, and they do not enter the electromagnetic radiation. So there must be permanent dipole moment in that molecule. There must be permanent electric dipole in that molecule. Okay, my voice is clear to all. जर मध्ये मध्ये तुटत असेल आवाज तर सांगा मला. हॅलो.
Yes, sir.
Yes, sir.
Okay. Now There are two types of changes occur in a molecule when it absorbs infrared radiations. Okay. First is a rotations. We have seen molecule rotates around itself. Molecule rotates around itself, and because of that rotation, that molecule has some energy. Again, that energy due to rotation depends upon the speed of that rotation. Different speed has different energy. That is called as rotational energy levels. In a molecule, there are different rotational energy levels. Okay. Now, infrared radiations has that much energy to change its rotational energy levels. The energy gap between two rotational energy levels is very less. So, the radiations gets absorbed and there is change in rotational energy level, that is called as rotational transitions. These are called as rotational transitions. Now such rotational transitions are of little use for the spectroscopy. For IR spectroscopy, in IR spectroscopy, we do not consider the rotational transitions. That rotational transitions is in Raman spectra, that are rotational and vibrational. It is microwave region. Mostly rotational transitions were taking place in microwave region. Okay. Another type of transition which are useful for us is the vibrational transitions. The position of atoms in the molecules are not fixed, just we have said. The bond between two atoms is not a rigid bond. That bond behave like a spring. That bond behave like a spring. It vibrates, it oscillates like a oscillator, it compresses, it elongates, it is compressing, it is elongating, it is bending, the bond angle is changing, it bends. Okay, these are called as vibrations. These are called as vibrations. And there are number of vibrations. There are number of vibration. Different modes of vibrations are there. There are different modes of vibration. Of these vibrations, that molecule has some energy. We call it as the vibrational energy. We call it as vibrational energy. Again, energy due to vibration depends upon the speed of vibration, oscillation. So we may say there are different vibrational energy levels also in that molecule. So by absorbing infrared radiations, that molecule may change its vibrational energy level from lower vibrational energy level to higher vibrational energy level. This is called vibrational excitation. This is called vibrational excitation. These vibrational excitations are more useful, or these vibrational excitations are studied in infrared spectroscopy. That's why infrared spectroscopy is called as vibrational spectroscopy. Okay. Now types of molecular vibrations. Mainly there are two types of vibrations: stretching and bending. Stretching vibrations means the bond angle remains same. Just like here, it is a triatomic molecule. This is one atom. This is another one. This is another one. Okay. Now stretching means bond length changes. Bond stretch होतो असा स्प्रिंगला आपण पकडून ओढलं आणि सोडून दिलं. ओढलं सोडून दिलं. That is stretching and compressing. Elongation and compression of bond length. While bond angle remains same, this bond angle do not change in stretching vibrations. Okay, so that is called stretching vibration. In this stretching vibration, there is change in interatomic distance along the bond axis. There is change in interatomic distance. That interatomic distance is called as bond length. So in stretching vibrations, there is change in bond length, while bond angle remains same. Such type of vibrations are called as stretching vibrations. Now there are two types of stretching vibrations. There are two types of stretching vibrations. Symmetric stretching, in which both bonds, these both atoms going away from the molecule, going away from this molecule, and again come close to this molecule. दोन्ही बॉन्ड एकदाच स्ट्रेच व्हायलेत आणि एकदाच इलॉंगेट व्हायलेत. एकदाच स्ट्रेचिंग, एकदाच इलॉंगेशन, सेम टाइम. At the same time, both atoms were stretching and elongating. That is called as symmetric stretching. That is called as symmetric stretching vibration. Another one type of stretching vibration is called as asymmetric stretching vibration. In asymmetric stretching vibration, one atom is compressing, one bond is compressing, whereas same at the same time another bond is elongating. एक बॉन्ड कंप्रेस होतो, एक बॉन्ड इलॉंगेट, जस्ट लाइक दिस वन. I have shown this in figure. एक बॉन्ड कंप्रेस होतो, एक बॉन्ड इलॉंगेट होतो. पुन्हा मग दुसरा जो इलॉंगेट झाला होता तो कंप्रेस होईल, कंप्रेस झालेला इलॉंगेट होईल. असिमेट्रिक मॉलिक्युलर सिमेट्री बिघडते. इथं मॉलिक्युलर सिमेट्री सारखी. Okay. So it is called as asymmetric stretching. It is called as asymmetric stretching. So these are the two types of stretching vibrations. Another one type of vibration is bending. There is change in angle between two bonds. There is change in angles between two bonds, whereas bond length remains same. In previous stretching, there is change in bond length, was constant. In bending vibrations, bond length is constant, bond angle is changing. Bond length is constant, bond angle is changing here. Okay. So these are called as bending vibrations. There are four types of bending vibrations. There are four types of bending vibrations. One is called as rocking. Rocking means both atoms move on same side. Both atoms moves on same side. Such vibrations are called as rocking vibrations. Second is scissoring. These bonds are moving like a scissor, blades of scissor. That is called scissoring. Wedging. This, this is called as out of plane wedging, and it is called as out of plane twisting. So these are the four types of vibrations. Now I will show you the different vibrations. Uh, you are able to see my fingers?
Yes, sir.
Okay. Now firstly I will explain you what is stretching vibrations. Okay. Now this is the bond angle. This one is the bond angle. This one. These are the two atoms, and this is the third atom. In stretching vibration, what happens? This bond angle remains same. These two atoms moves away from this one like this stretching and compressing, stretching, compressing. Okay, this is elongation, compression. Now, if these two atoms were compressing at the same time like this and elongating at the same time like this, then it is called as symmetric stretching vibration. Both atoms were elongating at the same time and compressing at the same time. It is called symmetric stretching. And if this is elongating and this one is compressing at the same time, at one time this bond is compressing and this bond is elongating, and again this bond is compressing, this bond is elongating, that is called asymmetric stretching. That is called asymmetric stretching. Okay, this is the symmetric and asymmetric stretching. Now we have to see what is the bending vibrations. Okay, now this is the bond length, these two are the bond length, this is the bond angle. In a bending vibration, what happens? Bond length remains same. In stretching vibration, this bond angle was same. In bending vibration, bond length is same, whereas bond angle is changing. Whereas bond angle is changing. Okay. So there are four types of bending vibrations. Rocking, first we have seen. In rocking, what happens? There are again two bonds on this side and on this side also. We have seen, I have seen only these two. In rocking vibrations, what happens? This bond vibrate like this, like this. Both bonds moves on same side. This bond angle is not changing, but this bond angle is changing. Which whatever atom is at this side, if we say like this, then this bond angle, this third bond angle is changing one, like this. This is called rocking vibrations. These are called as rocking vibrations. These are called as rocking vibrations. Okay. Now another second type of vibration, bending vibration is scissoring. These bonds are moves like a blade of scissor, like this, like this. Scissor ची blade कशी येते, दूर जातात जवळ येतात अशी. That's why these such vibrations are called as scissoring vibrations. These are called as scissoring vibrations. Okay. Now another one was the wedging vibrations. Wedging vibrations. What? Now this is the one plane. This is one plane. Now, how the vibration is like this: behind the plane, above the plane, behind the plane, above the plane. This is the plane. This is the plane of this bond, this molecule. Then the wedging vibrations are both molecules comes above the plane like this, go back to the plane like this at the same time. So such type vibrations are called as wedging vibrations. Okay. Now what is the twisting vibrations? If these are the bond, one goes behind the plane, one comes above the plane. And after some time this goes above the plane, this goes behind the plane. Like this twist, like this twisting, that is called as twisting type of vibration, that is called as twisting type of bending vibration. So there are four types of bending vibrations. First we call it as rocking, we call it as rocking vibrations. Then scissoring vibrations, then wedging vibrations, out of plane wedging, and these are the twisting vibrations. Okay. So such type of different vibrations are there in a polyatomic molecules. In a polyatomic molecules, such type of vibrations are there. Mainly two types: stretching vibrations and bending vibrations. So many times this question is asked: what are the types of vibrations in a molecule? So we have to give the first stretching vibrations, two types of vibrations: symmetric, asymmetric. Then the bending vibrations, four types of bending vibrations: rocking, scissoring, wedging, and twisting. Now we will see carbon dioxide molecule. Carbon dioxide molecule. Sorry, this is okay. This is the image of carbon monoxide. We see carbon dioxide molecule CO2. In CO2 molecule, it is CO2 molecule is a linear molecule. CO2 molecule कसा आहे? Linear molecule आहे CO2. तुम्हाला बोर्ड दिसतोय का इथं? एक मिनिट. मागचा बोर्ड दिसतोय माझा? बोर्डावर लिहिलेलं दिसतंय का? CO2 काढलेलं मी. हॅलो.
हो सर.
तर CO2 मॉलिक्यूल असा आहे लिनियर. कार्बन सेंटरला, ऑक्सिजन इकडे, ऑक्सिजन इकडे, एकीकडे. नाव दोन्हीकडं ऑक्सिजन आहेत. कार्बन आणि ऑक्सिजनचं डिस्टन्स सारखं आहे. कार्बन आणि ऑक्सिजनचं डिस्टन्स सारखं आहे. So this molecule is non-polar. This molecule does not contain permanent dipole. This molecule does not contain dipole. कुठल्याही ऑक्सिजनवर निगेटिव्ह चार्ज नाही किंवा कार्बनवर पॉझिटिव्ह चार्ज नाही, पार्शियल. दोन्हीवर सारखे चार्जेस आहेत. ओके. नाउ बट when we see the stretching vibrations of this molecule in symmetric stretching मध्ये काय होईल, ते दोन्ही ऑक्सिजन एकमेकापासून दूर जातील, एकमेकापासून जवळ येतील. ओके. In this situation also there is no change in bond length, म्हणजे there is no change in the इलेक्ट्रिकल डायपोल तयार होत नाही. पण समजा असिमेट्रिक स्ट्रेचिंग झालं कार्बन डायऑक्साइड मध्ये. In asymmetric stretching what happens, one bond elongates, another bond compresses. One bond is elongating, another bond is compressing. In this situation what happens, in this situation this bond हा ऑक्सिजन जवळ आहे, तो दूर आहे. ओके. मग अशा वेळेला ह्याच्यामध्ये डायपोल तयार होईल. ऑक्सिजनची इलेक्ट्रोनिगेटिव्हिटी जास्त आहे, तो ऑक्सिजन हा ऑक्सिजन पार्शियल निगेटिव्ह चार्ज देईल, हा पार्शियल पॉझिटिव्ह चार्ज कार्बनवरती. नाउ इट बिकम्स इलेक्ट्रिक डायपोल. Then such vibration, we get such vibrations absorbs infrared radiations. तो कार्बन डायऑक्साइड मॉलिक्यूल मध्ये आपल्याला फक्त असिमेट्रिक स्ट्रेचिंग मुळे ऍब्झॉर्प्शन मिळते. सिमेट्रिक स्ट्रेचिंग मुळे ऍब्झॉर्प्शन बँड मिळत नाही इन्फ्रारेड स्पेक्ट्रोस्कोपी मध्ये. ओके. Now vibrational frequencies.